Hi guys, the topic of discussion for today is diazotization. It is the reaction of primary amines with nitrous acid, in a result of which we get diazomium salt. This whole process is called diazotization. In this lecture, we are going to discuss about reaction of primary amine and nitrous acid. Now, which type of primary amine we will discuss? Alkyl primary amine and aryl primary amine. Furthermore, the reactions of secondary amine and tertiary amines will be discussed in the lectures to follow. So, how does this process take place? First of all, the definition should be learned by heart. Second, the mechanism underlying is important. We will start with a general preview. Generally, this reaction is written as like this: R and H2, it is for primary amine. First is for primary amine, primary amines. RNH2 in the presence of sodium nitrite and mineral acids like HCl, we are going to get R N triple bond N and Cl minus. This species is called diazomium salt. Diazomium salt, because it contains two nitrogen, it is diazo, and both the nitrogen have probability to get positively charged, which we will discuss in following minutes. Furthermore, we get two water molecules and a salt as a byproduct. Here we use two equivalent of HCl. How does this mechanism take place? The mechanism is like this. First of all, sodium nitrite, the structure of sodium nitrite is like this: O N double bond O. This sodium nitrite is being protonated in the presence of mineral acid like HCl, and the species we get is HCl. This proton takes this electron pair, and this chlorine leaves as a chloride ion, which is further taken by this sodium cation, and we get sodium chloride as a salt, and here we get OHNO or HNO2, which is nitrous acid. This nitrous acid is unstable, that is why it is produced in situ, means in a process. Nitrous acid. Now, this nitrous acid in the presence of further mineral acid will get dehydrated like this. We have OHNO and we have proton of acid. This proton takes this electron pair, and what we get, NOOH2 with a positive charge. This region leaves as a stable water molecule, and we get a species called NOR, nitrosonium ion, and structure is like this: N double bond O positive, or this lone pair comes here, and we get N triple bond O with a positive charge here. This is nitrosonium ion. This is the reactive part of this reaction. This nitrosonium ion is being attacked by the lone pairs of amines. Now if we have aromatic primary amine, we could write aromatic primary amine like this: RNH2, and here we have our lone pair, and this is nitrosonium ion with a positive charge. These electrons are being shifted to the empty orbitals of this nitrogen, and the species resulted is like this: R N N double bond O, and we have our two hydrogens, while this nitrogen becomes positively charged. Now there takes place a removal of proton, because this nitrogen is positively charged and it is electron deficient because it has coordinated its two electron. That is why this will take either electrons from this proton or this hydrogen, and this one of these hydrogens will leave as a proton. So we will write like this: R N double bond O, and we have our one proton here. After this, what we will get, this species will rearrange and a proton shift will take place like this. Rearrangement could take place easily: R N H and double bond. We just rearrange it for our convenience. This electron pair will come here, and this bond will be shifted towards this position, while this bond will this bond pair will be gained by oxygen, and the species resulted is R N double bond N OH, while in the presence of acid this oxygen part gets protonated, R N double bond N, and we have OH2, while this species leaves as a stable water molecule, and we gets R N double bond N positively charged, and this could come here and resonate. We will get R N triple bond N, a positive charge here. Now this is called diazomium, alkyl diazomium cation. Alkyl diazomium cation, and a chloride ion will come and will ionically bond to this species, and we will get diazomium salt, R N triple bond N positive and Cl minus. This is our diazomium salt. Furthermore, this alkyl diazomium cation is unstable, and what could possibly we get? We could get a carbocation. This bond will shift here and will adjust this positive charge, and we will get a carbocation plus nitrogen gas. This is our final species, and we could get a large amount of different mixture products or product of mixtures. To avoid these mixture, scientists prefer to use aryl amines, because aryl amines are far more stable than primary amines. The procedure is exactly same. We have our aniline here, N and H2. The nitrosonium ion is formed, and that nitrosonium ion is being attacked by this lone pair of aniline, and the species resulted is NH2 N double bond O, and here we have positive charge. Same proton removal takes place. N with a single H as one proton is being removed, and N double bond O. Now there will be a proton shift as that has occurred earlier. N double bond N OH, and this part will get now protonated by mineral acid, and we get a species like this. N, double bond N, and OH2 with a positive charge. This region will leave as a stable water molecule, and we will get positive charge here. That positive charge will be dispersed here like this, and this lone pair will come. N, triple bond N, and here is a positive charge. While we will from mineral acid we will get our chloride ion, mineral acid HCl. The byproducts will be NaCl and water. The whole reaction could be depicted as under. If we have aniline, NH2, and we use sodium nitrite in the presence of mineral acid HCl, 2 equivalent HCl, we will get our diazomium salt, and triple bond N plus and Cl minus, plus sodium chloride, our byproduct, and water molecule. Thanks.